Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this Techstrong Learning experience. My name is Cody, and welcome back to Techstrong Learning. Before we dive into today's session, I have just a couple of notes to review with everyone. First, as always, this session is being recorded, and we will be emailing you a link to access the on-demand recording shortly after we conclude this live session today. If you would like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. If you have specific questions, we do want you to send those into the Q&A tab on the right side of the screen. I know our presentation is going to run a little bit long, and so we may not have enough time for all of your questions. So do be sure to send those into that Q&A section, and we'll forward those on over to our speaker, who will hopefully get back to you after the fact. Last but not least, I will be selecting two of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible for this giveaway are to send in your chats, send in your questions, or to fill out our webinar survey. You'll find that in the resources section on the left side of your screen, but I'll also post that link in the chat towards the top of the hour and give you another reminder there. So without any further delay, our topic today is 5 time-saving hacks to find 500 hours. I'm joined today by Patrick Chang, VP of Prisma Cloud Global Solution Architects at Palo Alto Networks. So Patrick, thank you so much for joining us today on Techstrong Learning. I'll go ahead and pass the floor on over to you.
Hello, good morning, good afternoon. Thank you very much for joining the Prisma Cloud webinar today, titled 5 time saving hacks to find 500 hours. So thank you very much for your time today. Today we'll go through a series of slides, demo, as well as polling, so that we can all learn a little bit about cloud security. So with that said, let's get started. My name is Patrick Chang, Vice President of Prisma Cloud Global Solution Architect at Palo Alto Networks. In terms of agenda, we're going to cover the following things today. We will share a little bit about the cloud security challenges. What are some of the pain points and obstacles that customers face, specifically when they try to solve cloud security with a bunch of disconnected solutions. We're going to share 5 ways how Prisma Cloud can save you time and help improve the efficiency of your cloud security practitioners. We'll also show you how you can also help the developers to improve their productivity while dealing with security professionals. We'll talk about how we're offering a free cloud security risk assessment to every one of you, so you can get a free trial of Prisma Cloud. Okay, so let's continue right along. So what we want to do today is kind of talk a little bit about the cloud security problem from the perspective of a fictional organization called Acme Corporation. Okay, this may or may not look like your company, right? So but it will just help us in terms of framing the problem. 15,000 employee company, financial services firm, highly regulated, distributed workforce, moving to a mix of public cloud. Using a mixture of, on-prem and public cloud, doing lift and shift, which is just lifting and shifting existing workload to the cloud, plus also brand new cloud application development, right? And approximately 20 plus, security people that are focused on cloud security. So, may or may not look like your environment, but this is kind of like, gives us the framework to discuss the problems. So what we've seen is when customers go to cloud, they found that it takes a very long time and a lot of manual effort to figure out what is it that we have in the cloud. There's a better way to do that. Now, when you go to the cloud, many customers have told us that I got so many development teams, I got people doing lift and shift, I got people using CI/CD pipeline, pushing new things into the cloud. I just lose track of everything. I don't know what I have in the cloud, and if I don't know what I have in the cloud, how can I provide security? So that's a problem. So and there's no way that you can just ask the developers or people, just tell me what you've deployed. That kind of manual effort just doesn't cut it, right? So with Prisma Cloud, there's a better way. We can provide you with continuous visibility across all the deployed assets from a single pane of glass across multiple clouds. We also provide you with visibility risk analysis of more than 380 plus cloud services, and I'll define what cloud services means. And we'll also show you what change has been happening in each one of those assets. Okay, and then the benefit when you do this is that you can actually save up to 500 hours per year on your multi-cloud asset inventory. If your management team says, hey, I want to know what we have in the cloud, if you want to do manually, it'll take you a lot of time, but we can do automatically, as well as do automatic risk analysis. So with that said, I'm going to show you a demo. Okay, so what I'm going to do is I'm going to share the screen. All right, so what are we looking at here? So here's Prisma Cloud, and I'm going to switch to cloud security. So it's a SaaS solution. And what I'm going to first show you is how we can quickly give you an inventory of all the assets in your cloud environment. So once you give us the credentials to log into your cloud environment, and obviously we only need read, if you just want us to provide visibility and risk analysis and whatnot. Here we show that you are in the Acme Corporation, we find that they are running on Amazon, Azure, and Google, and other cloud providers. They have about 4,000 plus assets in Amazon. Okay, so when I click into that one, when we say we support a lot of different services, so what I mean by that is if you look at cloud service, here's a list of all the cloud services that we support on Amazon, and then Azure, it's a long list, okay? GCP, and then we also do the same thing with Oracle Cloud, OCI, IBM, right? So those are the cloud, and Alibaba Cloud. Okay, so those are clouds that we support. So once you give us the credentials, the read credentials to see, to log into cloud, basically, and then we can just use API, we can see a list of all the resources, okay? Second, you go, okay, well, I see there are a lot of them, but can you go deeper and show me each individual asset? Of course, each one of this is an individual asset, right? So this one is an RDS database instance, right? And what I'm going to show you is with cloud service, I'm going to say EC2. I'm going to look at all the Amazon EC2 instances. In this case, I have over 100 plus, right? Now, second thing, can I now click into each asset and see what it looks like? Okay, so here's the asset. You can see the asset ID. You can see the cloud type, service type. You can see the region it was deployed in. You can even see what is the OS that's running on that machine. Is Amazon Linux 2? Is it running Docker, or is it running Kubernetes? Like, you can see all these things. Second, we can also tell you if it has any misconfigurations or issues. So in this case, we found that there are a number of issues that happen, right? This EC2 has IAM role attached that has a S3 get object and list3 bucket permission. Why does that matter? Because if you look at these S3 get object and S3 list permissions, so these are permissions that gives the EC2 the ability to pull things out from S3. Maybe that's okay, but in other cases, maybe it's not, because that EC2 is not expected to pull things from S3 bucket. In that case, it might be an overly excessive permission given to the EC2. That's why it's a low severity, because it's not that critical. But you also can have serious issues like this one. You got a SQL injection and code injection attempted on this EC2 that actually has access to the S3 bucket that we showed earlier, and it's a bunch of other issues. So in 2 clicks, you can see the number of assets that you have, what are some of the issues. You can also see what kind of vulnerabilities they have, because in this case, it's a running virtual machine. And these are the vulnerabilities that we found inside this virtual machine. And then another really interesting thing customers want to know is, hey, tell me if something has changed to this specific EC2. Now, these are the vulnerabilities that we found over time. but we can also see that when something was changed, right? In this case, the resource state was updated. The resource state was updated. So you can even see, oh, something changed during that time. Well, what happened, right? Who did it? Who made these changes? So that is the first thing I wanted to show, which is Prisma Cloud gives you an inventory of everything that you have running in the cloud. We tell you what they are, give you interesting information about each one. We have policies that we've shipped out of the box to detect any misconfigurations, vulnerabilities, and that are excessive permissions. And we can also show you what actually has happened to that specific asset over time, right? So that's the first thing. Now, after you do that, then you go, well, but what you show is just very basic things about cloud security. Tell me what I have. But there's a lot more to it. The other problems I want to solve. And a lot of times, the user interfaces are too complicated, or in many cases, they're too many. Let me explain. A lot of times, and if you look at the list of projects that we listed out earlier, right? API security, data security, workload protection, visibility and compliance, the list goes on and on. What we found is that customers try to buy best of breed from a lot of different companies, and they end up with 5, 6, 7 different tools. That makes the whole cloud security journey very difficult, because your cloud security team would now have to pivot on multiple screens to look at all the different problems. But what the interesting thing is this, all the different problems may be related to the same asset, which I'm going to show you in a second, right? We provide a unified view of risk from multiple threat factors. We also provide you with customizable dashboards, compliance report, and control for governance. And then we also have a very interesting AI-based copilot that really streamline the user experience. If you look at Prisma Cloud, the kind of problem we can solve is not only do we solve the cloud security problems, but we also solve a tool consolidation problem, because we help you bring all these things together, all inside Prisma Cloud. And what that means is you will actually be able to solve problems with very few clicks and much faster. Okay? So with that said, I'm going to go over to the demo. Again, I'm going to switch over. So remember earlier, I showed you that we're looking at it as an asset, right? Now, if I click on this thing called attack path, for those of you who have been kind of dabbling in cloud security, you would have, have heard this term called attack path. It sounds like a very interesting name, but what exactly is it? What we found is when we show customers alerts like these, they said, yeah, I have, here's an asset with a bunch of vulnerabilities. Here's an asset with some misconfigurations and other things. That's interesting. Now, if you decide to buy a number of different tools, then you could have some tools that give you vulnerability of your virtual machine. Let's call the tool number 1. You have a tool number 2 that shows you, oh, this thing has excessive IAM permissions. You have other tool that detect threat, like there's data exfiltration. And then you have another one that says, hey, this one has excessive IAM permission because it has wildcard resource. So you can have a lot of different tools, all with their own interface, and each one of them telling you there's a problem with this asset. But when you take a step back and go, wait a minute, they all saying there's a problem, a different problem, but for the same asset. But if I am the security person and I want to know which of all my assets that I have, which one should we fix first? If I look at one alert from one tool, another alert from another tool, and alert from another tool, how do I get the holistic picture of which are the things I need to fix first? And that's where customers complain about tool fatigue. And it's just like, it's all over the place. And they said, and we asked them, well, how do you solve the problem? Oh, we try to send them to a SIEM. Well, how exactly would a SIEM be able to tie all these things together and say these 5 problems are related to the same asset? And asset number 1 has 5 problems. Asset number 2 has 2 problems. So you solve asset number 1. And so, well, through a lot of work, like finding that unique ID to tie things together, doing the right policy, like the list goes on and on and on. And I said, how long does that process take? They said, well, a long time, and it's not really working very well. So what you end up doing is you send all these different alerts from all these different tools to a SIEM or some other engine to correlate. It never does it well. Then you're left with a bunch of alerts. So we like to call that game alert and pray. You alert and you pray that somehow, some way, people will figure out what are the right things to fix and fix them. We have a different take. We believe that it makes more sense for you to see all the problems related to the same asset in the same view. In this case, this EC2 that we were looking at earlier has a bunch of alerts. But in this case, what we've done is we actually have what we call an attack path policy. In this case, the attack path policy is basically looking for, hey, is there SQL and code injection attempted on a specific endpoint where there's S2 data exfiltration risk on an EC2 instance that is publicly exposed to the internet, misconfigured with critical vulnerability, and have unusual data transfer activity. So in other words, instead of looking one alert from one tool on multiple tools, we provide all these capabilities under Prisma Cloud, number one. Number two, we now look for assets that fail multiple of these issues at the same time. And when they do that, they violate this policy, because this policy obviously is a multi-condition policy, right? It looks at condition A and B and C and D and E and F. When those things all happen, which is exactly what is happening here, we go, this asset is scary. That is how we can help you solve cloud security problems with one tool instead of multiple, and in a consolidated manner. So you can actually see that this asset is really scary. It is exposed to the internet, right? And we can see the path to the internet. We see that this thing has vulnerabilities. This thing has a misconfiguration. This thing has excessive IAM permissions to talk to S3 buckets. This thing also has unusual high volume data transfer, which means maybe data exfiltration is happening. This thing has code injection and SQL injection attempted at the endpoint, which is this VM. So that's the power of Prisma Cloud, which is instead of dealing with multiple tools and multiple alerts, and you just need to find a way to correlate all of them, it's all here. Okay? So that's the value of bringing everything together. Let me just look at, right. So second thing, I want to show you the customizable dashboard. So a lot of customers go, okay, well, that's interesting, but we're not going to go and click on each thing one at a time, right? Can you show me some dashboards that we can create on our own? Okay, so for example, if you say, hey, I want to create a new dashboard, okay, and then I'm going to just, create something like, I want to look at my overall asset trend, which I already showed. Alerts by severity. Let's say I want to show my compliance coverage. Oops. Okay. I want to see my compliance trend. And then you can move these things around. And next thing you know, you go, wow, look at these are the different compliance standards I'm using and how well I'm doing against. Here's the number of compliance trends. How many resources am I tracking? How many of them are failing policies that we have? How many of them are passing, right? You can also look at the number of alerts generated. How many of them are critical, high, medium, low, or informational? These are dashboards that you can create manually. And we also have out-of-the-box dashboards as well to help you. So the idea is you can easily create these dashboards to look at the things you really care about. And then you can print out these as reports and show it to your management team, okay? So another aspect of our UI is customers say, hey, Prisma Cloud has a lot of different capabilities, right? You just talked about, like, you guys do, security posture management, workload protection, API security, data security, threat detection. You do a bunch of things. And it takes time to learn because you have so much capability. You have a product that we can grow into over time because you have so many more capabilities that we don't even use today, and we're going to use it over time, as opposed to other point products that look great, but then you grow out of it because it has limited capability. Once you go beyond a single area that they cover, you go, but what about this and that and everything else? Then you go, well, we're working on them. Well, but I need it now. Prisma Cloud already has all these capabilities you can grow into. So we understand that we have a lot of capabilities, and customers say, hey, make it even easier for me and my users to learn your product. So we go, well, what if instead of learning the tool by reading the manual and going through training classes, can you ask questions? Of course we can ask questions. Like, what are my top risks? So here's a case where we have what we call a Prisma Cloud Copilot. This is a feature that we're working on. It is in private alpha. It is in private preview right now, where you can just ask questions. And once you ask questions, you can then click and it will show you the problem. So in this case, we go, yep, what are my top risks? That's the top one. We go, hey, focus on a policy with SQL injection attempted on a publicly exposed virtual machine, right? Very similar to one that we looked at earlier, except that one is a AWS virtual machine. This one is an Azure virtual machine. And then you can just click on it. And then you can see the same graph that I showed you earlier. You can click on each one and you can see very similar. And then, show me publicly exposed EC2 instances. So everybody has been enamored by ChatGPT, how you can just ask questions and it will give you an answer. We're basically doing the same thing here by giving you the ability to ask questions and then showing you the results. In this case, we're saying these are all the virtual machines that are exposed. And of course, you can make this bigger, right? You can see these are all the different virtual machines that are exposed externally, right? And you can see the attack path for each one, how they're exposed to the internet, and they can then drill down. So that is the interface that we are building to improve the usability, because we understand that we have a lot of capabilities. Some customers say, I don't want to learn by clicking around. Can you just let me do it ChatGPT style? So that's that, right? Next one. So far we've shown you, giving you a list of visibility, giving you a nice user interface. But the very next question customer asks is, okay, I need to now fix these problems because I don't want to be labeled as an alert and pray, okay? And believe me, we've seen a lot of customers in that camp of alert and pray. So how do you avoid to do alert and pray? Well, first of all, if you can consolidate everything into a single view, like what we've shown you, like the attack path alert, it will help you prioritize. I'll also show you how we have machine learning based anomaly detection for network user and workload threats. And then we also show you how to fix vulnerabilities that you discover, right? So, and the net benefit when you do that is you can actually save around 50% of the time spent on investigating these security issues, okay? So with that said, I'm gonna now show you the demo. So if you look at this, here is a list of alerts that we see, and I'm gonna consolidate this one. As you can see, these ones are all the critical and high severity alerts, and clearly the attack path policies are at the top, right? Because these are the ones that are really critical, right? Now, we also have plenty of other policy type as well. So for example, we also have config policies, data policies, IAM policies, network policies, and all these, but they don't have the same severity which is critical or high, critical for the attack path policies. And the reason being the following, right? If you just have something which is a misconfiguration, that in itself may not be severe enough to cause you to fix it. But if it is part of an attack path that is, hey, you have a misconfiguration for something that is exposed to the internet and something that has vulnerability and like all the different end conditions, if all those are true, then the attack path policy is of critical nature, but the underlying ones may not be as critical. So that's the power of this platform versus if you're doing multiple tools, multiple individual tools, each one of them will say, oh, this is critical in terms of IAM. This is critical from a workload protection. This is critical from a data perspective. This is critical from a misconfiguration. And you just go, my gosh, every one of these vendors are alert and pray. They alert, they go, my alert is most important and you need to deal with this, you need to deal with this, you need to deal with this. But you go, wait a minute. Are they all really critical? They may be critical for your specific product, but your product is so siloed, you're looking at just API security. Do I need to really fix that? Or do I need to fix something else for the workload piece or the identity piece? With Prisma, everything's tied together, so you don't have to take these guesses. You don't have to look at all the different tools. And when you do that, you can say, oh, here's that SQL injection thing that we looked at earlier. I'm going to click into it. And of course, that is the asset that we saw earlier. That has an issue, right? So that's the first thing, which is using the alert, using the attack path policies to stitch the most important things together. We can then say, hey, anything that violate these attack path policies are the ones that are most critical, which you need to address. Okay, so that's the first thing. Second thing, customers say, hey, if I look at this attack path policy, right? Let me click on this one again. This one is exposure to the internet. That is a risk. This one is vulnerability. That's a risk. Misconfiguration is a risk. Excessive permissions to an S3 bucket, those are risks. Risks are basically things where it could lead to a breach. It could lead to an incident. But do you, Prisma Cloud, actually detect actual threats as they happen? Not just risk, incident. And the analogy is telling me that my house has a pretty cheap lock for my front door. That is a risk. Telling me that someone just broke down my front door and are now walking upstairs into my master bedroom to steal my watch, that is an incident. I'm sure you all get that. Prisma Cloud does both. Exposure to the internet, vulnerability, misconfiguration, having access to S3 bucket with, let me click on this so you can see. Right, so here's an S3 bucket and I see the alerts, the misconfiguration alerts. I can also see that this thing has sensitive objects that are stored like PI data, financial information, right? So these are things, let me see. Yep, see, these are the data patterns like healthcare, PI data. Obviously, this is a demo, secret key. So these are all risks, but they're not actual incident yet. Can you detect actual threats? We do. So in this case, we say that, hey, we have observed unusually high volume of data transfer from this account. And you go, well, what do you mean unusual high volume? Because what is usual for one VM might be unusual for another one. How do you do that? Well, we learn. So with machine learning that monitor the egress behavior for every VM. Let's say this VM usually does about 100 kilobytes of egress a day. Today it's doing about 500 per hour. That's abnormal. What that also means is it could be sending data to a malicious website externally. Well, that's bad. So that's based on machine learning, and that's anomaly detection. Not based on a single signature. It's easy to build signatures, right? A lot of these policies that we have, right, like misconfigurations, these are signatures, right? Like, hey, we just want to detect that we're looking for specific things. Important, not enough. How can you create a signature to detect unusual high volume data transfer? You can say, oh, well, anything that sends more than 1,000 kilobytes per hour is abnormal. Well, why? Because certain VM may actually do that, every minute, because it is an external, website hosting virtual machine. Whereas an internal machine that doesn't do that, then maybe 1,000 kilobytes is abnormal. So we watch out for vendors that say we do threat detection. And when you say, how do you do threat detection? And they say, well, we got policies. Well, so you just have signatures. How do you detect anomalies, things that are not normal? You got to use machine learning. Not easy to do. We ingest 1 trillion flow log events every day across all our customers. And with machine learning model to learn for each individual virtual machine. So when we say this is unusual high volume, it's not across all the VM, it's for this specific VM. Code injection, SQL injection, same kind of thing, where we detect actual threats that have been lobbied against the API or the app that's actually running on this thing. And we also use a combination of signatures or policies and machine learning as well. So last, I'm going to show you something which customers have find very interesting. They said, hey, listen, we do vulnerability scanning. And we go, well, how do you do vulnerability scanning? Well, we got these traditional vulnerability scanning solutions, which you know very well, for the runtime virtual machines and containers and other things. We go, okay, how's that working for you? Well, we get all these vulnerabilities, but my engineer said, you got so many of them in the runtime, I don't know which ones to fix. Okay. And then some customers go, well, I got a better solution because give me 1 second. Are you guys still seeing my, give me 1 second. Okay, you're still seeing this. Okay, you're still seeing the cons. Okay, that's good. So, and then other customers say, well, we are gonna start scanning the VM images and the container images before they get deployed. So they got these shift left solutions, and you know who they are. And I go, well, how's that working out? They go, well, slightly better, but my engineers still complain. There are too many vulnerabilities that you want us to fix. And they go, which ones are even relevant? Specifically, which ones are relevant in the runtime environment? So we go, well, Prisma Cloud can do better than both because we have ability to look at images and packages for scanning for vulnerability before deployment. But we also have the ability to look at what things are actually deployed in the runtime and then use that to solve the problem. So in this case, your shift left, scanning solutions, I'm not going to name the names. I mean, you know who they are. They can tell you, hey, I scanned the image, I scanned the package, I found that they have critical high vulnerability. 3,000 of them are exploitable, and about 2.8 thousand are patchable. Patchable meaning that there's a package with a higher version, with a newer version number that does not have that vulnerability. And you go, well, that's great because those are the ones you really can fix. Otherwise, if it's not patchable, meaning there's no version of the package without the vulnerability, your engineers don't really know how to fix the problem because they're not going to rewrite the whole thing. So all the shift left vendors that can say these are the vulnerabilities that exist in your package and images, they stop right about here. And you go, well, that's better than 14,000, but you still have 2.8 thousand. That's still a lot. But what if we can tell you how many of those packages that are critical and high vulnerability, exploitable and patchable, how many of them are actually in use? What does in use mean? In use means that these packages are actually used by your runtime VM and containers. And you go, how does that solve the problem? Well, guess what? If you know that only those 7 are even used in the runtime environment, those are the 7 that you need to address first before you address anything else. So whenever we show this to the developers, they go, "Oh my gosh, this is a game changer," because instead of me and the security team screaming at each other about why do I need to solve 2,800 vulnerabilities, I only have to solve these 7 because those are the ones in use. So that's the first thing. Second thing, customers say, "Well, I like to have a global view to understand the impact of fixing these vulnerabilities." Well, let's take a look at that, right? So here's a case where we go, here's a vulnerability. Let's see which vulnerability it is. It is found in Log4j. And of course, we all remember Log4j. But when it happened a couple of years ago, everybody was scrambling, answering the following questions. Do I have Log4j? Where are they in the runtime environment? How exposed are we? And more importantly, where did they come from? Because we need to eliminate that Log4j, or you bump it up to a newer version of Log4j that does not have that vulnerability. That took many customers days, if not weeks, to sort out. Imagine you have the following view 3 years ago. Here's the package Log4j. We see that that package is referenced by another package in a repo. That package, of course, is Log4j, has been embedded into several images. There are 2 images that have been built. These are Docker images, and then another one for a VM template. And then what you find is that these packages actually have been deployed as containers and VMs into the runtime environment. So it gives you that one single holistic view of the impact of this particular vulnerability from this package across your entire software development lifecycle, from the packages in your Git repo to the images that have been built and stored in the registry to the containers that have been deployed or the VM that have been deployed in the runtime environment. And then people go, well, that's interesting, but how do I fix it? Well, in the past, you have to go back to the developers and go, well, you need to fix it, or you need to try to solve each problem one at a time. Imagine having this ability to say, hey, here are the list of assets that are impacted by this package, right? The Log4j. And you can see what is the impact, right? If you fix this, it's 2% of the code vulnerabilities across one repo, but it's 85% of all the runtime holes. So it gives you a fixed impact. Now you can try to fix it individually by like submitting a pull request, submitting a Jira ticket, right? These ones take time because if you submit a Jira ticket, it was another alert and pray kind of scenario. But if you submit a pull request, this changes the game. Because what this means is we are allowing the security team to trigger a pull request. The pull request basically is a request to change something. In this case, the change is to bump up the version of this package to a newer version that doesn't have that vulnerability. Now, that pull request will be sitting inside the developer's GitHub, GitLab, Bitbucket kind of a tool. When they log into in the morning, go, oh, there's a pull request that was generated by the security team. I need to address this. Imagine that scenario versus, oh, I will just generate alerts and then hopefully the developers will figure out. That's alert and pray, which unfortunately is not always answered because you generate an alert. How long would it take for the alert to be routed to the right team, the right engineer, and then for them to figure out what is the right thing to fix? Ask yourself that question. Many customers say that takes days, weeks, months. How about never? Instead, the security team can just trigger this request. It is now sitting in the developer queue inside the GitHub, GitLab, Bitbucket repo, and they can figure, do they want to merge? So it's not like the security team is pushing it into production. They're just making a request. The developer can now figure out if they want to accept that request. So hopefully what I've just shown you is very simple ways to solve the remediation problem, right? So let me continue now. So policy enforcement, I know we have about 9 minutes, so I'll speed things up. So Prisma Cloud has over 2,000 plus out-the-box policies that detect, attack path, misconfiguration, vulnerability, identity data. So basically, remember the list of problems that I asked up front? Do you have an active project? We actually solve all those problems in a single product. And of course, we have out-the-box policies, many of them signatures, but we also have many anomaly detection based on machine learning. You can also customize a policy, and we can also help you do auto remediation of misconfiguration. And the net benefit when you can get all these is you spend less time dealing with policies, per year. So if I go back to governance, right? So we have a lot of different type of policies that we ship out of the box, right? You can see audit, bill. These are audit. Let me see. Policy type. Policy type is a better one. So anomaly detection. These are all the policies that detect that use machine learning to detect threats. API security policies, attack path, which we talked about a lot. Config data. So altogether, we have over 2,000 plus policies. Number one. Number two, customers say, I want to customize these policies. I want to build my own policy. How would I do that? Well, it's very simple. You can actually just say, hey, I want to build a new policy to check for, let's say, misconfiguration. You can just say, hey, let's say, check service. In this case, I'm going to check, let's say, AWS App Nash. I want to see if I have this, let me see. Let's say API name, App Nash. And then you can then check, whether there's any issue associated with this thing. So this is how easy it is to build an alert. And in fact, let me show you another one, which is expose asset with S3. So if I were to show you this one, so this one is a, yep. So here, oops. Give me 1 second. Let me go back to search. Yep. Let's look at this guy. Oh. Okay. I'm not clicking on the right policy here. This one. You know what? I'm going to skip past this one. I was going to show you a policy where we can actually modify the change, modify the alert very quickly. Since we're running out of time, let me continue. So that's the customizable part. And then the other one is automatic remediation. So a lot of these policies, the configuration policies, let me show you. Go back to the policy type, configuration, and then I'm going to add one more, which is remediable. Okay. So if I click on any one of these, you will see that we actually have a remediation. Oh, hold on. Oh, yes. Sorry, that wasn't my mistake. Okay. So here's a GCP policy. And when we say remediation, we provide remediation steps that we recommend, but we also can actually execute a CLI command to fix that specific misconfiguration. In this case, the misconfiguration, a GCP firewall rule exposes GKE clusters. So if you say, hey, I want to do auto remediation, what we can do is you can create an alert rule that says, hey, anytime that this policy is violated, we will automatically trigger that CLI command to actually fix the misconfiguration. So you don't even have to deal with this. Now, this is something that it's entirely up to you. You can choose to just alert on the policy, or you can also choose to remediate the policy whenever the policy is violated. It's entirely up to you. And again, the product gives you the power to decide, how you actually handle remediation. And then last but not the least, I talked about, shift left, since a number of you are actually doing shift left. So what we found is customers say, hey, I want to detect and remediate security issues as early as possible before they become issues in the runtime environment. So customers say, hey, it'll be great if you can give my developers the tools to fix security problems early on, right? So that's exactly what we offer. So what I'm going to show you is, imagine you have an IDE, whether it's a Visual Studio, IntelliJ, and while you're coding, in this case, the user, I'm a developer. Oh, actually, you know what? I recognize I'm not sharing my screen. Give me 1 second. Home tab. I'm going to say project. Okay. So that's the first thing I want to show. This is an IDE, right? It looks like a classic kind of Visual Studio, IntelliJ, where, where the developer might be writing code. In this case, they're writing a Terraform file to deploy an EC2 instance. And while they're still writing code, we can actually scan that Terraform template and tell you that, hey, there's a problem with this particular Terraform template. We got all these different problems, right? EC2 EBS is not optimized. EBS volume do not have encrypted launch configuration. These are misconfiguration policies that we have out the box. In this case, these policies actually checking for misconfigurations and issues like or secrets that are exposed, all in the Terraform template before these things even get deployed in the runtime. So if you want your developers to help fix problems, this is something that they can use right away to fix problems before these things get deployed. Second, customers say, hey, this requires us to kind of install your plugin in the IDE that my developers use. That's interesting. But can you give us another gate, if you will? Can you give us a gate at the Git level? And we can do that as well. So in this case, what I'm going to show you is, this one, where we have a GitHub, GitLab, or Bitbucket plugin, where we can automatically scan all the pull requests that your engineers make. So in other words, earlier, I showed you how a security person can generate pull requests to fix a security problem, and then the engineers can decide whether they want to merge and approve. Similarly, if an engineer were to do their own pull request, they're making changes to the code, we can also scan those change requests and see if they have any problem, right? So in this case, it's like, oh, EC2 not configured with IMDS v2, SS key being exposed, SS key being exposed, EBS volume do not have encrypted launch volume. And then for other issues that haven't been fixed, we even give you the EC button. In this case, the developer, when they check in code, they can go, oh, I got a problem. Prisma Cloud flags it. If I want to fix it, how do I fix it? You can just say commit suggestion, then we'll fix the code, and then they can merge. So these are two simple, techniques that engineers can really use. And the beauty of it is they don't have to learn a different tool. They are just using the existing tool, whether it is the IDE, the Git, to identify and solve problems. And we give them the EC button to fix the problem right there and then. And the last thing I want to show you is, what about CI/CD? Because CI/CD is becoming a hot topic for a lot of customers. We also solve that as well. After we've scanned the CI/CD environment, we can say, hey, you have a problem with your CI/CD configuration. And I'm just going to show you one. So we have a bunch of policies, just like we have on the runtime side. And then we can say, hey, so for this, we can say there is a direct poison pipeline execution. So these are policies that we ship out of the box. In this case, what we're looking for is the ability of an attacker with access to a source control system, but without access to the build environment, to manipulate the build process by injecting malicious code. So these are the kind of problems, for those of you who said you have CI/CD project, these are the kind of problems that customers are starting to think about. But we are the front runner in this because we actually bought a company called Cider Security. They have a team that really pioneers Cider's CI/CD security, and they actually contributed to the OWASP top 10 attacks when it comes to CI/CD security. And those policies have been built into the product. And if you look at what it essentially does is, these are the open events that trigger this thing. And imagine having a view like this, where you can see which users have access to the repo. This repo can trigger the following, deployment into the pipeline, and these pipeline have access to credential. You can almost look at that as, wow, that looks like the queue chain, except that there's not a queue chain, a classic queue chain, except it's looking at what things could go wrong in my pre-built, pre-deployment environment. And if you see a problem like this, you go, yeah, I need to fix this, because these users, what if they get hacked? They can then have access to the pipeline that can go to and have access to credentials. So for those of you who say you have CI/CD security problems that you want to solve in in calendar year 2024, we also have that covered. I'm just going to go and just wrap it up by saying, hey, if you look at what Prisma Cloud can offer, we can simplify the inventory and then the risk analysis. We have a great UI that simplify the visualization, that make it very easy for you to use the product. We also have, attack path and for prioritization, and it's also easy for you to do investigation. with out-of-the-box policies. Apologize that we didn't quite get the configuration part going. The demo set up incorrectly. Apologize. And last but not the least, we also have shift left capabilities that help your developers solve problems on their own, so that they don't, so that those problems don't leak out into the runtime environment. So that's about all that I have time for today. I want to say one more thing. If you find this interesting, guess what? You can get part of it for free, because we are offering a free cloud security risk assessment where you can actually get a report from us, basically the same thing that I showed you earlier today, to give you an assessment of what is the risk of your environment, do you have any problems, and how can we help. So be sure to, I'm sure we have your contact information, and we'll be reaching out to you and seeing if you're interested in the cloud security risk assessment. So with that said, I want to thank you for your time. Hopefully you've learned something interesting here today, and we look forward to doing a free cloud risk assessment with you, so you can see whether you have problems that you want to solve and how we can help. So with that said, I'll stop and say thank you. Thank you very much for your time, and we look forward to talking to you.
Awesome. So Patrick, thank you so much for joining us today. I know we had to cut things a little bit short, so all the questions that we did receive today will be sure to send over to you in an email. But once again, thank you so much for presenting all this information for us today. Additional notes for our audience before I release you: we will be emailing you the recording from today's session, so just hold tight. You should be getting that in your inbox here shortly. And I'd also like to just make a call out to our chat. I'll go ahead and post our link to our survey once more. It's also pinned to the top and in the handouts, but you guys filling this out for us really goes a long way, and we want to make sure that we bring you the biggest and the best webinars that we can. So please do let us know your feedback there in that survey. We really appreciate it. So once again, thank you to Patrick for joining us, and to everyone here in our audience. Thank you so much for spending your time with us today. We appreciate you, and we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect.